Okay, good afternoon. So today 29 students. See, when I shared the brochure, I clearly mentioned only the interested students have to apply. If you are not interested, then why did you apply? 72 registered for the course and the attendance is not even 50%. So if you are not interested, tell your friends no need to come. Okay, this was not mandatory. You don't get any kind of marks for this. So I wanted only genuinely interested students. If you are not interested, you can leave. Okay. Anyway, okay. So is my screen visible to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
So today we will start with 3D. Okay. Then we will also demonstrate the software that were left out on the very first day. So what I think that it will be better if I draw a 3D figure, a simple 3D figure, and then take this figure to all the softwares and then demonstrate it. Okay, so for that I hope by now everybody knows the basics of AutoCAD 2D. Those who didn't know, I think they attended yesterday's class and now they are clear. Okay, so whenever we enter in AutoCAD, as I said, you have to see what is the workspace you are in. Okay, for 2D it's generally drafting and annotation, and for 3D we have to switch it to 3D modeling. Alright, so okay, but whether it is 2D or 3D, you have to always set up your page limit. Okay, so for that what I have to do will help me.
MV setup.
MV setup, very good. So I have to write MV setup. Then no metric, then full, let's say 200 by 200. Okay, so this has been created. Now if you see here, it is written top 2D wireframe, and here also this view cube, here it is the top view. Alright, so now in order to switch the view, what I can do, I can click here. If you see here, top is written, I click here, and if I go to say front, the front wait, I have to switch to 3D. Okay, so initially this was top view, right? Then I can select say the front view. Okay, front view is like this. So here let me draw a simple figure. I will discuss all these features one by one, but like just to start with and to demonstrate the other software, what I'll do, I will simply draw a simple figure, but it is simple, but you know, having some overhanging kind of its component. Okay, and for that I can take a spline. Okay, this is called spline 3 point. So let's start with here. Okay, I will go like this, this, like this, and say, like this, double enter. Okay, now let's have this view. Then again, let's draw a spline from this point. Okay. Okay. So basically it is looking like this. This is having a very sharp, you know, yes, let's smooth in this. Okay. Somewhat it is smooth, so it's looking like this. Alright, so what I will do, I will like form a pipe here. Okay, I will form a pipe along this part. For that I can draw a circle anywhere. Here let me draw a circle, a small circle. Okay, then I have to use this sweep button. So sweep this circle, enter, then the path is this as well. I have to join it. Okay, before sweeping I have to join these two lines. So join, then this and these are joined. Okay, now single pass. Alright, so I will simply sweep this circle, okay, through this part. It has been swept. Now you will not see, because here the view is like 2D wireframe. So if I change the view to say realistic, you will see. Okay, so this has been created. Okay, so now what we'll do, we will try to print this. Okay, we'll try to print this. Why I have chosen this kind of structure? Because you will see the supports and all coming into it. Okay, so that's why I have chosen this one. So this one has to be solid. Okay, this one has to be solid. Say this one is enclosed both at the start and the end. So this is not like a hollow pipe. So this is a solid thing. Okay, if you want to print anything, it has to be solid. The bulb we created yesterday, you will not be able to print it. Okay, why? Because you know, the surface of the bulb doesn't have any thickness. Okay, surface of the bulb doesn't have any kind of thickness. So the printer will definitely ask for the thickness of the surface, and a line doesn't have any thickness. If a line doesn't have any thickness, then if you extrude a line, then of course that surface will not be having any thickness too, isn't it? So but in this case I have swept it like this, and this is enclosed, so this is a solid object. Okay. So like that you can, you know, form any kind of 3D figure, which we will learn today and tomorrow. But suppose this is the figure that you have created, this is the 3D model that you have created, and now you want to print it. Okay, you have bought a printer, now you want to print it. So for that what was the step, next step? Anybody remembers what I have to do? Which software we discussed in our first class? What was it? Anyone?
CD
You have to export the
Screen
STL file.
slicer.
No, to export the same software can be used. Okay, to export the STL file. After exporting the STL file, you have to use slicer to open that STL file and generate Z code file. Okay, so let's come back to this. So I need to export the STL file now, stereolithography file. So stereolithography file can be exported like this, clicking here, export, then STL is not here, so other formats you have to click, other formats, then let's say desktop, then say 3D printing, and let's click, let's create another folder, and pipe, let's call it pipe. Okay, so enter, and I will rename it as pipe. Okay, pipe, and you see this is STL, the file format is STL, so it has to be saved. If you click save, it is not finished yet. You see the icon has been changed to a rectangle. Now it is asking for select solids or watertight meshes. So there I have to select this, click, then it says one found. If it says not found any object, that means there is a issue with the figure. That means maybe it doesn't have any kind of thickness, or there can be any kind of issue. Okay, so once it is selected, now I have to press enter, then automatically my file will be created here. Pipe, you see this pipe type S 3D object it is showing, but it's a STL file. Okay, so now what's next? We will tell. Slicer. So using slicer you can slice the objects, but using slicer you can also create the Z code file. So Z code file is generally used to run the simulation. That means how the arm will move from one point to another. That thing can be simulated using that Z code file. So let's open slicer. So I think the link was already, this PPT was already shared to you. So I hope you have downloaded all the softwares, this slicer, chemotics and GrabCAD. Downloading these two is very easy. For GrabCAD you have to register just like AutoCAD. Okay, so slicer, it's installed here already. So let's open it. So this is how the slicer window looks like. So there I have to add, from where I will have to add that file, 3D printing pipe, this STL file. Remember, it cannot open CAD file directly. You see the known files, STL, object files, AMF files, 3MF files. So the CAD file that you will save, it will be saved in which format? You will tell me. The AutoCAD files are generally saved in which format?
DWG.
So DWG files it cannot read, so that's why it has to be exported as STL file. So the STL file will be read. So STL file is clicked, and now it has been imported here. Now you see this, this what can I say, this base depicts the base of the printer. So the base of the printer is like this, that's why it's coming like this. Now you can export the G-code file here, or what I can do, I can even see how layer by layer it is done. Okay, so the layer heights and all, it can be fixed here. Okay, these things will be discussed with you in details in your I think 2nd February or 3rd February class. But anyway, these things can be done, but in order to generate the layers and all, I have to click on layers, it will get generated. Okay, it is taking some time. Till then, let's export the G-code file here. So G-code file pipe, you see here the extension is like .gcode, .gco, .g, like that. So I can save as it is. That's the G-code file. Okay. Let's wait. Yeah, you see this has been generated. Now what is this? What is this green objects? What these green objects are called?
Support.
Support. These are support materials. Now you see, if I, still taking time.
Support.
Yes, support. Okay. Now you see, this is the first layer. Okay, this is the first layer, and if we go up layer by layer, you can see, in the first layer there is nothing but only support. Only one point is touching here, there only the main material, structure will be deposited. But if we go one by one like this, you can see that yellow portion is the the main object, and the main objects are generally filled with some kind of, again, support materials, that is denoted by the pink color, and all these green colored things, they are nothing but only support that has to be removed. We have already seen how the support materials are removed. So this will be removed like this. So you see, now because of the support, the materials can be deposited here. Okay, otherwise if the supports were not formed, how the materials would have been deposited here? So since the support structures are being formed, so now the materials are getting deposited here. So if you go up, you see parallelly all the supports are getting built up automatically. We didn't design the support, isn't it? We didn't design the support, automatically it has understood, and you see how beautiful it is. It's going up like this, and like this. Okay, all right. So you understood how support materials are formed and placed. So you can, as an engineer, what you have to do is deciding the orientation where it takes minimum support materials. What will happen by minimizing the support materials? Two things. First is you will be saving money, because the cost of printing the actual object will be same in any direction, in any orientation, whether you print it like this, like this, like that, it doesn't matter. In any of the orientation, the total material of this object will be same. But by orienting it with your judgment, you can cut down the price of the or the volume of the support materials, isn't it? So the volume of the support materials, how to reduce that can be also seen in GraphCAD. That will be you will be able to see it. Okay, so the G code we have already exported. Okay, we have already exported. Scale we can, like if we put 50, the object will be it will get smaller. Okay, split, when in AutoCAD one option is there called solid union. So if you don't do solid union, then the materials are separated. Okay, the materials will remain separated, the parts will remain separated. That means just like in 2D, what we did, we joined these two splines, this spline number 2, spline number 1. So if we suppose hadn't joined these two splines, then this portion and this portion would remain separated. Then we could have splitted it and printed it separately. Okay, so anyway, that is like how this slicer software helps you. So you can go to 2D, there also you can see this preview, then 3D, then layers. In layers you will see everything going from the 0th layer to the last layer, like that. So in 2D it is getting formed. Now you see, this is layer by layer it is showing. Okay, say this is like at a height of 37.20, this will be like this, Okay, anyway, let's see how schematics run the simulation, the G code file, the slicer. So I have to open schematics. Okay. Open a G code file. The G code file. The schematics cannot open STL files, so only the G code file has been shown here. Okay, if I choose all file, the STL file will also come, but it cannot read that file. So anyway, this 5.g code I will open. Okay, I hope it's wait, it's still loading. Okay. Loaded. Now you see, this is just this schematics part is just their part. If we remove this, so you see this is how it's done. Okay, this is the first the 3D arm, it will go like this. Let's do it faster. Okay, this is how the 3D arm rotates. This arm rotate and it will start depositing. Okay. Like this, like this. You see, so you can understand how the arm is moving, although it doesn't have any kind of significance towards the output, but you can have an idea how the arm will rotate and how it will get printed. Okay, so by playing with the code, by playing with the Z code, maybe the CSC students can control how the arm will move. So if you want it the other way around, you have to edit the Z code file, then only it is possible. Otherwise, by default, it will automatically go in one direction. Okay. Alright, so using schematics you can see how these things are simulated. Then finally, after getting a rough idea how this thing is going to be formed, how the support structure will look like, you can finally go for printing. Or you can skip these two, slicer and schematics, you can skip and directly you can import the STL file in GraphCAD. Okay, in order to generate the G code file you need slicer, but in order to print you don't need slicer. Directly you can go to this GraphCAD or this kind of software. Okay, so let's open GraphCAD. So this is the actual printer. It looks like this. Here the resins will be there, and at the top part it will get printed. Okay. So automatically this is like assuming that the default printer is Fortus 380 micron. Okay, there are many printers, you can select any one. So all are from the same company, I think, from Fortus, and there you can choose the printer and you can go on. But before that you have to add the model first. So which file I have to import, who will tell? Which file I have to import, which extension?
STL.
STL. So I can, here you can see this 3D object was STL, isn't it? So I can open the STL file. So it is coming. Okay, Now you can orient like this. Okay, then this, like this you can orient, and suppose I have oriented it like this. And now what I will do, I will have to add my supports. So in order to add the supports, you have to click here, support settings. So sorry, first you have to click the object, then this support settings. There support style, you can select smart. That means automatically it will understand what kind of material, what kind of support it needs. Okay, the things in details you will be taught in your later classes. Okay, so I have selected smart. Okay, then I have to slice. Okay, I have to slice the materials like this. I have to slice it. Just getting sliced. 380 micron means the layer thickness will be 380 micron. That is also the nozzle diameter. Okay, so it is getting sliced. Let's wait. It will take time. You have to be patient. Okay, you see. So let's see an animation. Layer range up to layer. Okay, and then let's play the animation and see how it's done. So these are all the layers. Okay, getting built. So here model material, support material, everything is clicked. That's why it's showing. If you go, it will look like this. Now in slicer also this can be done. Then what is the use of this? You know what happens, you can see the estimates here. If you click here it is saying my model material. Someone please write down these things. For this I will show a different orientation. We will compare. Okay, so for this the model material is 109.15 cc. Okay, and the support material is 78.81 cc. Okay, so as an engineer, what can you do next in order to save the material? It's like this time I will suppose orient it like this. I don't know, it will be like having more or small. Let's estimate. Let's say লিখিছিলা না কোনোবা এটো 109 আৰু কি আছিল support material
78.81.
So let's see in this particular orientation how much it will be. see now the support material. Earlier the model material was how much? 101. It's slightly more, but that difference will not be significant difference. Okay,
Sir, 109, sir.
109. Yeah, that difference will not be significant. Maybe because of the placement, some materials get lost initially. That can be one of the reason. But more or less, it will be almost same. But you see, support material, how significantly it has been reduced to 48. So just like a monkey, you cannot like orient it in all the possible directions to see how the support materials is getting changed. You have to use your own common sense, isn't it? So before orienting, you have to visualize, you have to use your visualization capacity and determine. In this particular figure, of course it is difficult, but you know some definite shapes when you are going to print, it is not that difficult to determine how to reduce the support materials. Alright, so after you know deciding that okay, my support material is this, and one more thing, reducing the support material cost or amount or volume cannot be the only criteria. Okay, it cannot be the only criteria. Suppose in one case, just I am giving one example. Suppose you are printing a face. Okay, you are printing a face. Then do you want your support material to be like present on the front side of the face? No, of course not. Then of course you will be placing your head like this. That means with the face upward. Then you will be getting rid of the support material on the front side of the face. Okay, instead of turning it upside down. That is also a different issue. That means where you want the support materials and all those things. There are some very good softwares where you can even design the support materials. I hope you will be able to see the software when you will be demonstrated these things in details, but just this is the basic how it can be, the orientation can be decided. Okay, now here also you can see, if I click here, it is asking support style, then what kind of support style should be there. So should I use the model material? If you click model material, then it will, for the support, it will use the same material that is getting used for the model. Or otherwise, if you use like high density infill, then what will happen, not only the support, say inside this particular object, generally you will get the option inside what do you want. Okay, inside of this structure what do you want. It cannot be a hollow pipe, that is for sure, because it needs to be connected. So in that case, one option is there that you can have very like high density infill. That means wire mesh sort of thing. Okay, that can be used. Or if you use the model material directly, then it will be a very solid object. It will be strong, of course, but you will be increasing the material also. Maybe you don't require that kind of solid object, only the appearance is enough. So in that case, you can go for infilling with some high density mesh sort of thing. Okay, instead of using the actual material as infill. Alright, so that's it. Now let's go back to AutoCAD and learn 3D in details. Okay. what I'll do, I am sharing two figures there in the group, in the WhatsApp group. I have shared two figures, and let's try to draw this in 3D. First step being always, one thing I want to say, it may not be your style, but I generally prefer to draw all the possible figures in 2 dimension first, okay, then take it to 3D. One reason is that sometimes the trim function and all those things, they don't work in 3D properly, so I prefer drawing everything in 2D, then like modeling the 3D version of it. Okay, so before that, just let me show some of the tools. Okay, you don't have to know all the tools, of course, but some of the tools I am just showing. One very important tool is extrude. Okay, if you select extrude, see, it depends now. If I have created one rectangle here, so if I extrude, okay, this 2D wireframe is selected, the view, I will go for realistic. So now let's say extrude. So if I select the rectangle, then it will be extruded like a box. Okay, but suppose I have drawn a rectangle with some lines here, so all the lines are different. Okay, then if I use extrude, okay, like this, this will be a hollow one. Alright, now if I have to print, you will not be able to print one of these two figures. Which one you will not be able to print? Can anybody tell me? And why?
Second one,
Second one.
because it's a line.
What is the reason?
Because it's made of lines,
It's made
no
of
thickness.
lines, so the printer will not understand what is the thickness of this surface. Okay, the printer will not understand that. So for that, what you can do, you can draw like this. Okay, then you have to draw like another you have to draw another inner rectangle here. Okay, like this. So now if we go for extrude, then it will not get extruded. You have to use the press pull button. So press pull, if I use here, it will be like this. So this can be printed because it has some definite thickness. So press pull I prefer than extrude, because if you know how to use press pull, then you don't need to use extrude. Okay, so for press pull, if we like select this one, it is acting like extrude only. Okay, but if you select this thing, it will be press pull here, but if we select this thing, it will be press pull here. So it's a very strong tool, just like your trim in AutoCAD. Press pull is a very strong tool, so I generally prefer doing press pull instead of extrude. Okay, and of course you can draw box, cone, sphere, pyramid like this. If you select pyramid here, you can draw like this and like this, but most of the times, as I said, drawing the 2D figure is okay, and it is preferable than going for the 3D one. Okay, so that's why I personally have never used these things. Okay, sphere and all. So for a sphere, what will happen? You have to select a radius, a point, as simple as that. But since I like develop the 3D model from the 2D diagram, so I will use the revolve function. Yes, I will draw a semicircle first, then I will revolve it like that. Okay, but of course if you want it to be like a solid one, then you have to go for this sphere. Okay, because it is, you see the name, creates a 3D solid sphere. Okay, similarly pyramid and all these things can be drawn here. Okay, so those things are okay, but now suppose I have placed it here. Okay, I have placed it here, and I want this ball, this sphere to be removed. Okay, I want this sphere to be removed, and there should be some kind of depression in the box. The depression should be equivalent to the intersection portion of the sphere and the box. In that case, I will have to use this. Okay, so let's subtract. If you don't know how this function works, just place your button here. Okay, it will automatically show. You see, combines selected 3D solids or 2D regions by subtraction. So you see the diagram carefully. The green one has to be removed. The green one gets removed, okay, from the gray one, leaving with the red one. So which one should be selected first? If you click that button, the box or the sphere?
Box.
The box. So I will have to select the box first, then enter, and then select the sphere first, second, then enter. Then you see it has been removed like this. Similarly, as I said earlier that okay, now these two things are these two are separate. Okay, these two are separate. So this one and this one, they are separate. So that means what happened, if they are separate, if I click here and I click on the line, red line here, then it will go like this. Okay, so sometimes it may create a problem. So I want to like combine these two as one particular one figure. Then in that case I have to go for solid union. Okay, solid union, that means click on solid union, click the first object, enter, click the second object. Oh wait, I think I have to select all the objects at a go. First, second, then enter. Okay, now you see they are formed as one object. Okay, so these things can be done. Knowing this thing is sufficiently enough. If you have, you know, some kind of smartness of your own, by knowing these tools sufficiently, this will be like what, intersection, solid intersect. That means only the intersected portion will be there. So here you can see 1 and 2, so the intersected portion will be left out. You cannot go for intersection here because now it has become only one particular figure. But if I press Ctrl Z, now I can go for the intersection. So I select here. Okay, maybe select here. See, only the intersected portion has come out. So okay, the less you play with these tools, it is better for you, because you know playing in the 3D plane is much more tougher than playing in the 2D plane. So I prefer forming all the objects in 2D first, then converting it to 3D, then assemble it accordingly. And in order to assemble it, the most important thing that is used is like this one, move gizmo. Gizmo means this one, XYZ. This is called gizmo. And sorry, not this one, this colored. So here, move gizmo, rotate gizmo, scale gizmo, and no gizmo. So generally mostly used to are this one, move and rotate. So what will happen if this move gizmo is selected, then if I click on this arrow, particular green arrow, you see it is the green line has been shown. So after clicking on this green line, you can move it in this direction like this. Okay, then it can be moved in this directions like this, and it can be moved here like that. Okay, if we select rotate gizmo, then what will happen? A sphere sort of thing will appear with 3 axes or axis of rotation, you can say. The green one, okay, so sorry, the red one, if I select, so it will get rotated like this. You can select, you can write down the angle here, or generally if you have to rotate it like 90-degree angle, then you can choose the ortho mode to be on. So if the ortho mode is on, either it will be in this direction or this direction or this, like that. So it has been rotated like that. So again like this, here it will be say like this. Okay, it has been rotated. Okay, suppose you have to move this and join it here to this point. Okay, so in that case I am not sure whether it can be done or not, because the next thing that can be done is move. So move this object, select it. Okay, then a base point you can select. So the base point, let me select say this one, this point, and you can move, choose the auto mode to be off, you can move and place it here. It has been moved. Similarly, if you have to copy, then from this to say to this point, it has been copied. Okay, you see it has been copied here. Alright, so you need to practice a lot to master here, and all these things, trim and these things. There are 3D mirror also you can use, like you can create an object, a mirror image of the 3D object. These things are not generally used so much. Okay, if you want, you can anyway learn. In YouTube you will see lots of videos of basics. If you have interest, you will definitely learn. So anyway, already discussed this thing, so let's draw the diagrams that are shared in the WhatsApp group, isn't it? So let's close this. Why I am closing it? Just to ensure that you know. Okay, one more thing is there, that is called this dynamic UCS. So this dynamic UCS also, it's a very important tool. Suppose you have to draw a line. So when you draw a line, it gets created here on the plane, on the XY plane, but you want a line to be created on this surface. Okay, on this surface. So in that case, this dynamic UCS should be on. Okay, this dynamic UCS should be on. So if you like select here, see on this plane, what this line has been drawn. So if you have to move this to the midpoint of this, then I will have to simply say copy this, and which point? This point. this point will be moved where the midpoint. Where is the midpoint? This is the midpoint. Okay, so it has been moved here. Okay, understood? So you will see when we draw all this, just simply watch. আজি তোমালোকে হেৰি কৰিব নালাগে, লাইক নিজে কৰিব নালাগে, নিজে কৰাৰ কাৰণে you will get sufficient time. আজি just চোৱা, just watch. Okay, so I prefer 2D. Okay, I prefer 2D first, and suppose I will draw the first diagram, not the camera. Okay, camera will be the second. First, let's start with the an easy one. I hope it's an easy one. If the dimensions are given properly, it will be an easy one. Okay, we will see. Now you have to decide, you have to decide, you have to draw all the components separately, and you have to create a mental map. Okay, you have to create a mental map in your brain like this. এখন দেখাব পাৰিলে ভাল আছিল ৰবা, let me share this. So let's prepare our strategy first, how we are going to do it. That is very important. Okay, so what do you think, how it can be drawn? Any idea? Can anybody give any idea?
Sir, first of the top view base to one alone.
Okay, base, the entire base or only this part? I think it will be better to keep this and this separated, isn't it? Let's draw this one. Okay, let's draw this one first, then this one, then I can draw a triangle here. Okay, so alright, let's do this. So MV setup. Now metric 1, width will be how much? 200 by 200 will be sufficient anyway. 200 by 200. Okay. So let's first 18 plus এখানে কিমান হ'ব কৈ দিয়াচোন, এখানে ইয়াৰ পৰা ইয়ালৈকে it will be 60 minus 18, 42 minus 15, 27. Am I correct? From this point to this point, the base of the triangle, what will be the base of the triangle? Is it 60 minus 18, 42 minus 15, 27? Hone no? What do you think?
Yes, sir.
Yes.
So let's draw that. So I will and the width will be 9 plus 12 plus 9, 9 9 18, 30. So 30 and 27. Okay, let's see. So ortho mode on, so this way it will be 30, then this way it will be 27. Okay, then again 30, then again 27. Okay, now I need to taper. Okay, chamfering. So chamfer, then right click, distance how much? 9, second also 9, where this one and this one. If you have to repeat any kind of activity, simply press space. So space, this and this. Okay, my this thing is complete. Now let's draw that part. Okay, this one, anywhere I can draw. Here it's 30, then it will go 18, 30, it will come like this. Then I can draw an arc. What type of arc should I choose? And let's draw a circle only. Center radius, this one, and radius will be how much? 15. Okay, let's trim this portion. এইটো যে কি নাটক হৈছে মই নাজানো দেই, এবাৰত নাযায় মানে। Okay, ঠিক আছে। I need another circle there. এইটো আমি লাষ্টত ৰাখিম দিয়া। Now let's now what is left? Triangle. Triangle is of 27. Okay, then height is how much? What is the height? Is it 30 minus 9? 21.
Yes, sir.
Okay, 21. Auto mode off, connected, done. Okay, fair enough. Let's now move to circle to আঁকিয়ে লওঁ একেবাৰে ন, যেটো সৰু circle আছে পিছত মুভ কৰি দিম তাতে 7.5. Okay, now I will go to 3D modeling. Okay, then 2D wireframe থাকিব দিয়াচোন, then it becomes easier to choose. Let's select this. So what I will do first, I will have to use which feature here? Press pull. Extrude হলে এডালকে তোমাৰ হেৰি হ'ব, হলো হ'ব। So press pull. So press pull by how much amount? So it is asking, you see, specify extrusion height. So by how much?
9.
9. So let's write 9. then this one should be by what should be the amount?
30.
Okay, 30. Then this one should be 7, right? 7. All right, now it's time to join. So in order to join, I have to simply use move. So if I select here move, so I think I will join this point with this point. Done. Then this triangle, this has to be, first rotated. Okay, rotated with the ortho mode on. So okay, this the cube with the gizmo and all, that will come only when realistic is chosen. তেতিয়াহে আহিব. So এতিয়া মই rotate কৰিম এটো এফালে like this. Okay, then again rotate it by the this axis. Done. Okay, now let's again switch on my 2D wireframe. So this has to be karbar heri mute howa nai, mute korila. This I will select the midpoint, this midpoint. Okay, this midpoint will be ortho mode off, then it will be brought and placed here. Okay, done. Let's see the realistic view. It's coming. Okay,
Sir, etu solid union koribo laga howa nai ni?
solid union lastot korim, eta separate hoi thakok. So tumi it can be placed, just tumi solid union nokorile ki hobo, if I select only this will be selected, if I select only this will be selected. Now all these three are separated. Okay, so এতিয়া মই কি কৰিলো, what I have to do, I have to draw a circle here. So ইয়াৰ কাৰণে I need a reference point to নাই, so I have to draw a line. So a line should be drawn from this point to this point. You will be able to draw the line only when this dynamic UCS is on. Okay, otherwise your line will be drawn not on this surface but on the plane, always on the plane. So now this line has been selected, so I can move my this circle here. Okay, this circle from the center to the midpoint here. I can't delete so I can now press pull and remove the material down there like that, remove the material down there like that. All right, so this, okay, so you see it has been completed. Now the basic things, all those things can be, I have to move. So I can color before going.
Sir, press pull korte sir tolor base kini to thakibo no?
তলৰ বেছখিনি মানে তলপিনে নাথাকে, প্ৰেছ পুলত সেইটো ভাল, তোমাৰ যদি ইট অটোমেটিক্যালি আন্ডাৰষ্টেণ্ডছ, সেইটো অটোমেটিক ৰিমুভ কৰি দিছে। চোৱা ঠিক আছে, automatically gets removed. Okay, you can give color I have to type matte. Okay, মেট নহয় তুমি বেলেগকেও কালাৰ দিব পাৰা হেতুত মানে তোমাৰ মেটেৰিয়েল এড হৈ যায় ডাইৰেক্টলি ইউ ক্যান গিভ এনি কাইন্ড অফ ৰিয়েলিষ্টিক মেটেৰিয়েলছ কিছুমান সাৰফেস টেক্সচাৰ থকা মেটেৰিয়েল দিব পাৰা তাতে বাট কালাৰ এনেকে ৰাইট ক্লিক কৰি তোমালোকে কালাৰ দিব পাৰা ইয়াতে সো ৰেড দিলো ইয়াতে তোমাৰ হেৰি কৰি ইয়াতে মই গ্ৰীন দিলো কালাৰ চেঞ্জ কৰি ইয়াতে মই ব্লু দিলো হৈ গ'ল এতিয়া I have to union solid union this and this enter union now I need to move so in order to move now my gizmo has to be changed to move gizmo okay then this option will come so what you can do you can delete all these things are not required okay understood see এখিনি এটো কালাৰটো কিয় এনেকুৱা হ'ল
স্যার লাইনটো থকাৰ কাৰণে স্যাৰ
yes good লাইনটো আছিলে ন okay anyway এতিয়াতো ইউনিয়ন কৰি দিলো এতিয়া আৰু একো কৰিব নোৱাৰা সো ইউনিয়ন কৰাৰ আগতে সব চেক কৰি লবা ঠিক আছে all right হৈ গ'ল ইজি হয় 3D মডেলিং জাস্ট অলপমান হেৰিটো লাগিব আৰু তোমাৰ সেন্স লাগিব তা ক্যামেৰাটো আকো নে কি কোৱা let's do the camera so for the camera right MV setup no metric the paper width কিমান হ'ব ক্যামেৰাটোৰ কাৰণে same we can take 200 let's go to drafting and annotations check whether your trim function is working or not if the trim function is not working let's not proceed it's working all right so what is your plan for the camera it's even easier isn't it so how many 2D figures I have to draw who will tell me how many 2D figures I have to draw
6 I guess
6 good so shall I draw like this main body first it's like height will be how much is it 50 or 30 50 yeah 50 so 50 then 100 then 50 then 100 okay then one small portion at the top is there that will be like again how much 100 then the height is 10 I think 10 then yeah 100 again like this yeah okay now I can draw that trapezoid directly instead of going for a rectangle so it's your smartness what you need to draw first the top view or the side view for that portion now which is at the top let's show here for that portion which is at the top it will be like stupid to draw this and then extrude
side view
directly I can draw this trapezium isn't it I can draw this trapezium and then press and pull so I'll do that okay so for that let me draw how much it will be. 15 plus, is it 15 plus 15? 30. Okay, 30. Then it will go up by 10, then it will come by an amount. How much? It was not 15 plus 15. কিমান আছিলে third semester? What is the width of the camera?
Sir, 30 দিছিলো আমি
30 দিছিলা? Okay, so ওপৰৰ হেতু কিমান হ'ব?
Sir, 45 degree draw কৰি ললে intersect য'ত কৰে
Okay, good. মোৰ আকৌ angle 45 ত draw হয় নে নহয় হেতু এটা problem কালি নহলে. So suppose 50 45 ত draw নহয়.
তো মিলাই দিছিলো আৰু এটা এনেকে
ঠিক আছে, এনেকৈ আঁকি দিছোঁ আৰু কিবা এটা. যেনে ট্ৰিমো নহয় মানে কি যে হৈছে. Okay, that's that portion. Then the small one, let me draw it like কিমান হয় সাইজটো সৰু বক্সটোৰ ৰাইট সাইডৰ 10 by 10 মান হ'ব চাগে. It is 15 10 by 10. এইটো ডাইমেনশনটো ইমান মেটাৰ নকৰে আৰু হা তোমাৰ. So you are doing something, you will anyway know the dimension. ফিগাৰত আছে বুলি ইমান টাইম ওয়েষ্ট নকৰো. আৰু এটা সার্কেল আছে ইয়াতে, সার্কেলটো কিমান 10 ৰেডিয়াস. আৰু এটা সার্কেল আছে, this circle is like
25.
Is anything left? No, right? No, nothing is left. So let's go to 3D modeling. 3D modeling, then extrude I mean press pull. So press pull as this should be by an amount of how much? 30. Okay, this should be by an amount of same 30. Okay, this should be by an amount of 32, isn't it? Then this should be by an amount of 5. This should be by an amount of 5, and this should be by an amount of
20.
Okay, now let's my rotate gizmo will work only if it is in realistic mode. So let's go for rotation. So ortho mode is on, so I can directly rotate it. Okay, let me directly write down angle 90. Okay, this one should be rotated by 90 again. Okay, now let's move this, this has to be moved. This point should be moved and placed here. This has been kept separated, okay, because they look separated. Okay, now this has to be rotated this way, that way 90. Okay, then in this axis again 90. It is in this way, na? 180 to right. Okay, so I have to move. Here it will be a problem, you know. I don't have any reference point here, so where to keep. So let's draw a line. Then I can select the, you know, if this way I can select the midpoint. Let's see if it works. So move this, then selecting the midpoint here, and then selecting the midpoint here. Okay, it has worked. Good. Then for this part, let's look at where it is situated. Let's look at it first. Okay, let's draw some line and create a point here. So like this way, if my dynamic UCS has to be on to select that point. So this way 15 কিমান আছে এটো 15 ত সেন্টারটো হয় না I don't think so.
Sir, এটা corner 15 or 15 ত হয়
no হেৰিটো তোমাৰ সার্কেলটো
So 15 center to 15 হয়
15 না ঠিক আছে বাৰু 15 আৰু ইফালে কিমান ইফালে 15 ইফালেও হেৰি কৰি দিওঁ ইফালে এটা কৰ্নাৰটো কিমানত আছে এটা কৰ্নাৰ কোৱাচোন 15 and this way 15. Okay, I can select that. Okay, can go for 15 and then 15. Abo eto figure othe problem amar rete ko problem nai no, so I can select, I can move. So etia move korute মোৰ অলপ problem হ'ব, so মই কি কৰিম এটো move কৰি লও আগতে অলপ ইপিনে. So now I will switch my 2D wireframe. So etia maybe easier for me to, you know, place কৰি দিম okay. This line I can now delete. Okay, this circle I can delete. Similarly this one can be moved. Like which point I have to select? This one, no? This one off, then this one here, and remove this line. Now let's again switch on my realistic. Okay, তলত গুচি গ'ল দেখোন ঠিক আছে উঠাই নিম পিছত. Now I have to rotate. I have to rotate my gizmo this side 90. Okay, done. Then I need to create one reference point. Okay, here ortho mode on কিমানত হ'ব
30 to
I think it is the center combining both the box, isn't it?
yes sir.
Okay, so it will be
So
like
30 to height to
total height was how much 60, was it 60?
yes sir.
Okay, it will be 30 and this way it will be 50. Okay, So I have to again switch on my 2D wireframe, then move. This one is for move, then enter. Let's not this center, okay, that center, and then place it here. Okay, so I think completed. Now let's color it. So let's color it.
Sir, line to trim কৰিব লাগিছিলে গতে
কোনটো লাইন?
sir এটো sir বনাই দিছে
সেইবিলাক
Reference line.
ৰেফাৰেন্স লাইন বিলাক এইটো আমি ডিলিট কৰি দিম. আই উইল শো হাউ. তো মই গ্ৰীন দিলো, এইটো কালাৰ সাপোজ কালাৰ দিলো, okay. Now what I'll do, I will solid union this object, this object, this object, this, enter. All are solid union. Now I will move. Okay, move gizmo. So this, if I select here, it will be, it can be moved. Let it go there. Let it go there. Then I can delete everything here. Okay. Then again I can bring it here, bring it there. Okay, or maybe when I'm not here. Okay, understood? Yeah, to the line is again. That's why it's becoming green. So the basics you have understood.
yes sir
So shall we try one more? Let me see if I have any figure. A complicated figure. Half an hour is left, no? Okay, we can do. Okay. Now you guide me, okay? Now you guide me what to do, what you have to do. You have to guide. Okay. Think another one. Let me download that. Okay, let's prepare our strategy now for this. Koba ha, tomaloke koba etia ki korim koasun one by one. What should I do first? First I have to create the base. then this one, then this one, then okay, one more thing I have not shown you, that is called loft. Okay, loft, let me show you loft. Okay. So front view, set up. So here actually front view ঠিক নাছিলে, তো মই টপ ভিউত কৰিব লাগিছিল। Suppose I have drawn one, circle here, okay, and I have drawn another circle here. Now this circle has to be moved upward. So what I will do, I will click on the circle, then move gizmo, right? Move gizmo will work only in the realistic mode. So realistic, so this, and I will move it to here. Suppose I have one more circle, one more circle, so like this, and let's move it here. Now I need to draw a figure connecting all this. Okay, then I will have to use this option called loft. So if I select loft, this and this, it will be connected like this, then this automatically it will be connected like this. You see how a beautiful object has been created like this. See, similarly revolve to I think তোমালোকক দেখালৈ নেকি যোৱাকালি। Revolve is also like it's a very third semester students, have I shown you revolve in your normal class? No?
Sir, section dig এবাৰ দেখাইছিল।
Section dig দেখাইছে, yes, এদিক দেখুৱা নাই that semester. So revolve is like to generate something which is like symmetric in look and circular in shape, not exactly circular, but like it revolves around a plane like that. I think I have drawn one horai to the section D students, isn't it?
Yes, sir.
I can draw that now also to show the others. So I will go to front. Okay. So for that, okay, let me take an axis first, then one line which comes like this, like this, then spline maybe, okay, then maybe another line, this is my 1/2. So there I can use the revolve like this to draw. Say I can select everything except this, delete, revolve, select everything there. Then around which axis? So around this axis I want to revolve that. Okay, so it will come out to be something like this. Okay, so the line, the axis around which it has to be revolved, and the line which has to be revolved, you need to draw only these two things, then automatically. But will you be able to print this? Will you be able to print this using 3D printer?
Sir, solid নহয় তো base খিনি.
No, you will not be able to print it. Okay, in order to print it, what you have to do, you have to draw another line like parallel to it, and so that, and then close. Okay, you have to close it also like this. So you have to draw means another, of course you will copy or offset whatever you do, but you have to draw another line just by side of it, and you have to draw it. The thickness will be whatever the thickness that you want. Then you revolve, then you will be able to convert it to STL file. Otherwise you will not be able to, because the surface that was created is not, it doesn't have any kind of thickness. That's the problem. Okay, so understood? Revolve, loft you have understood. So why sweep I have shown in the beginning of the class. So anything that is drawn here, like this, okay, like this, and you want to suppose there is a pentagon, see the problem, it's not getting created. That's why I prefer drawing in 2D. Okay, that's why I prefer drawing in 2D. Suppose you draw anything. Can I draw a circle here? Okay, circle. Then I can use realistic. Then I can sweep. This throughout this one. You see, this circle has been swept along this path. Ultimately, a solid pipe has been created. Okay. So is it interesting? You have to just practice.
Yes, sir.
You have to just practice. Just know the tool. You have to practice, and you have to be patient. If you want your drawing to be good, then precision is must. You cannot draw anything without dimension. If you try to draw anything without dimension, it will look, why my hora is not looking good? Because I didn't follow any kind of dimension. That's why. Okay, first you like define your dimension, then you start drawing. Then always your diagram, your model will look beautiful. The mechanical engineering students, they need to draw gears and all. So the gears can be like drawn, suppose only this portion, and this one is here. So you can rotate it, you can revolve, and you can create the gear here. Okay, right? the civil engineering third semester students, you have already drawn the plan view of the building, okay, from the top, how it looks like. So the walls are already drawn in your case. So what you have to do, you have to simply extrude, you have to simply use press and pull and build up the walls, okay. Then your building will get ready. Of course not, you have to give the doors and everything, but those all things can be, you know, drawn separately in 2D. Then those things can be assembled. You see, if we know how to use the tools, and you have at least an IQ of 100, then definitely you will be able to draw. This is not rocket science. You don't need an engineering degree to develop models, to draw, right? That's why drafting is a course, diploma course. It is taught in the ITI colleges. So of course they create only two-dimensional drawings, but still, in order to know AutoCAD, you don't need any kind of degree. It's basic sense. But as an engineer, always brings, you know, some kind of advantage. If you know AutoCAD, if you know these things, then you will be able to utilize. You will be able to utilize your brain in a better way and come up with something which the normal person will not be able to do, right? So let's keep the we will like draw these things, the last figure, tomorrow, and also I will download 2 or 3 objects which can be drawn there. Don't expect me to like teach how to draw face using Blender and all, okay. Of course I don't know those things. If you want to, you know, learn these things, you have to take separate course in Blender, then, but it's okay if you don't know those things. You are an engineer, you don't have to develop gaming characters, isn't it? Okay, then if you got interested, then you can practice tonight, or tomorrow anyway. We'll draw and 2 or 3 more figures so that everything becomes clear to you. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.